3.1 task, or 3.1 task part 1. Our goal will be to solve quadratic equations graphically and algebraically, make connections between solving quadratic equations and graphing functions, and how we can use graphs to solve quadratic equations. And if you remember correctly, we actually already know what it means to solve. If you look at a quadratic, okay, this is the vertex, this is the y-intercept, and these are the x-intercepts. And we spent time finding those in Unit 2. Well, when you're asked to solve, you're actually asked to find the x's of the x-intercepts, because those are often where important things happen in the real world. So, as we have learned, quadratic functions can be very useful models for a lot of real-world situations. They are part of understanding the motion of objects, business and economic models, and many other applications. Using quadratic functions often requires solving a quadratic equation. So if you were given the quadratic equation x squared plus 2x plus 1, how would you solve it? What solutions would you get? If you were in class, I would have had you do this with your group using your own old skills, and there were 4 different ways that you could solve it. 1, you could pop it in your calculator and graph it, see where it crosses the x-axis. The other way, you could factor it, figure out what multiplies to make 1, but adds to make 2, and you would see that it's 1 and 1. Okay, and those are your x-intercepts, so you know it would cross the x-axis at -1, 0. You could complete the square and turn it into vertex form, where you do half the middle number and square it. And whatever you add on this side, you subtract on this side. And then in vertex form, you would see your vertex is -1, 0, which also means it's an x-intercept because the y is 0. Or you could use that new way I taught you where you found -b over 2a from standard form. All 3 of those, though, would have given you this graph. Okay, you're at -1, 0, and your a is 1, so over 1, up 1. And you can see that it crosses the x-axis when x is -1. However, unfortunately, sometimes you can't see the answer that easily. So, here's what we can do. It says solve the equation algebraically. We could try to factor it, but there's nothing that multiplies to make 4 and adds to make -6. So instead, I'm going to go ahead and complete the square. Put my spaces in. Okay, and then I do half the middle number. So x minus 3 squared. -3 times -3 is 9, and if I add 9 here, I can subtract 9 here. And 4 minus 9 is -5. So I've turned it into vertex form. And then you guys really should be looking at your yellow sheet. And your yellow sheet for graphing vertex form says identify A, H, and K. Well, remember that's y equals a, x minus h squared plus k. So in this case, my a is 1, my h is a +3, and my k is a -5. Again, I'm getting this off my yellow sheet. So my vertex is 3, -5. Okay? Your yellow sheet will then say to plug in 0 for x. So you could plug in a 0 right here. And if you did that, and then put it in your calculator, I am telling you that will give you a -4, which means, or sorry, a +4, which that means that is your y-intercept. And actually, you could have done that by looking at standard form, because remember, the c value in standard form is your y-intercept. Again, I'm going fast because this is just a fill-in video, so pause or slow down if necessary. And we're going to graph. So we're going to go over 3, down 5. We're going to cross the y-axis at 4. It's going to fold in half, have an axis of symmetry at x equals 3 or x equals h, which is what your yellow sheet will tell you. And that means if I have a dot right here, we'd also have a dot right here. So you have enough to complete the graph. Goodness. Okay, and then looking at that, you can see that the domain is negative infinity to infinity, because if you had a little guy walking on here, as he walks up this way, he goes left forever, and as he walks up this way, he goes right forever. And then remember, range is up and down. The lowest he can go is -5, and the highest he can go is infinity. So your range is -5, infinity. But we still have not actually solved it, because if you look at my y or my x-intercepts, I'm not sure if they're actually on a point or if they're in the middle. So this is the new thing that we're going to do. And remember, this is a develop with the understanding task. So you're going to copy it down, and we're going to work with it, and it still may be really fuzzy until we play with it for a few more days. But we're going to start with our vertex form, but we're going to let y equal 0. And if you'd been in class, I would have asked why we would let y equal 0. And that is because, remember, the x-intercepts are when y is 0. So your first step would be to add 5 to both sides. So you get x minus 3 squared equals +5. The next step is to get rid of this squared. And remember, the inverse, or the opposite of a square, is a square root. So you square root both sides. The square and the square root cancel out. So you'll get x minus 3 equals plus or minus the square root of 5. And you may be asking yourself, where does this plus or minus come in? And so in class we did a big discussion, but the idea is this. In elementary school, if I said, what's the square root of 4? Or what number times itself makes 4, you would say 2. Or what's the square root of 25? You would say 5. But now we're in high school, we write it in a more sophisticated way. We say x squared equals 4. Or again, what number times itself makes 4? Well, to solve that, you square root both sides. And yes, you get 2, but you would also get -2, because 2 times 2 is 4, and -2 times -2 is also 4. So here we just want the positive quick answer, but here we want every answer. So you'll see when I fill in the pink sheet that you always have to add a plus or minus. So that's where this came from. And unfortunately here, the square root of 5 is a decimal, so we're just going to leave it. But we could rewrite this as x minus 3 equals the square root of 5, and x minus 3 equals negative the square root of 5, and we're going to keep solving. So step 1 would be to add 3 to both sides, because we need to get rid of that -3. And you're actually done. X equals 3 plus the square root of 5 That's one answer. And x equals 3 minus the square root of 5. That's another answer. And you may ask yourself, how is that an answer? Well, if you put this in the calculator, this would give you 5.24. And if you put 3 minus the square root of 5 in the calculator, it would give you 0.7, I want to say 3. Now let's go back and look at our graph. Oh, hey, look. This dot right here could totally be at 5.24. And if I had drawn this a little better, yeah, that could have been at 0.73. So our solutions are the x-intercepts of 0.73 and 5.24. And then again, remember this is a develop understanding task, so this is one of the harder problems. Here's what I'm going to have you do to get the rest of your task points. I want you to graph number 3, fill in everything you can, so domain, range, vertex, axis of symmetry, y-intercept, and then please attempt to solve. I will tell you number 3 is easier. You won't have an ugly square root of 5 in it. And then once you've done that, come and see me. We can discuss it and you can get your task points back. Thank you.